In this video, we're going to be talking about how we can use our measure of central tendency and our measures of variability to discuss what our data set really looks like. And the first way that we're going to talk about for doing that is using what is called Chebyshev's rule. And Chebyshev's rule is going to give us a general idea of how much data is going to fall within certain ranges of our central tendency, or in this case, our mean. So the way that we're going to talk about that is we're going to say how much data falls within one standard deviation of the mean. So we're going to say one standard deviation, and we're going to say the mean, or mu, plus or minus 1 sigma, or we could say x bar plus or minus 1s. And Chebyshev's rule doesn't really give us any useful information about how much data falls within this. However, if we go up in our range, and we go to 2 standard deviations, so we have mu plus or minus 2 sigma, or x bar plus or minus 2s. Chebyshev's rule states that at least 3 out of 4, or 3/4 of our data, is going to fall within that range. So 3/4 of the data is within this range. And for 3 standard deviations, if we expand it out a little bit more, we have mu plus or minus 3 sigma, or we have x bar plus or minus 3s. Chebyshev's rule states that we have 8 out of every 9 data points that we have, or 8/9 of our data, is going to fall within this range. And we can generalize this rule a little bit further. So our generalization is going to state that 1 minus 1 over k squared of our data is going to fall within k standard deviations. And this is Chebyshev's rule. And Chebyshev's rule is a generalization, meaning that we don't really care what the distribution is going to look like. The distribution can have any general shape, but no matter what shape that this distribution is going to have, these rules should hold at least relatively true. The other rule that we have for describing our data is called the empirical rule, or what is more commonly referred to as the 68, 95, 99.7 rule. And this rule makes an assumption about what our data set actually looks like. So the assumption that's being made is that the data set has this mound kind of shape, which means it looks kind of like the normal distribution or the Gaussian distribution, where we have a symmetric distribution where it looks the same on either side of the mean, where the mean has a lot more probability of occurring, and that probability gets smaller and smaller as you get further and further away from the mean. And the way that this empirical rule works is it's again going to be dealing with a standard deviation from the mean. So we can talk about the mean as either being our x bar or our mu. And we're going to be talking about how much of the data is going to fall within a given number of standard deviations. So if we have plus or minus 1 standard deviation, so plus or minus 1s, or plus or minus 1 sigma, we're going to have 68% of our data. So this is 68% of our data. If we have plus or minus 2 standard deviations, so plus or minus 2s, or plus or minus 2 sigma, we have 95% of our data. And finally, if we have plus or minus 3s, or plus or minus 3 sigma, we have 99.7% of our data. And we're going to be using this rule a lot as we move forward and kind of expanding upon this and looking at how much data falls within a particular range of our data when we have these kind of assumptions about our distribution. And normally the distribution that we're going to be dealing with is this Gaussian or normal distribution.